Quadratic formula today, a little bit of vocabulary for what it's for. Roots of a quadratic equation. Roots are synonyms for what are the solutions, what are the answers, what are the zeros. So it may be find the zeros, find the roots, find the solutions, solve. Those all say the same thing. The quadratic formula is a formula for solving quadratic equations. And specifically, let's make this an equation so it equals something. And we want it equals 0 if we're going to be able to use the quadratic formula. Quadratic means 2 is the biggest exponent on the x in the equation. So far, we have been solving quadratic equations by factoring, and that works if we have integer or fraction answers, but it does not work if we have complex answers or if we have square roots in the answers. We've also done completing the square. That works for everything, because some of our completing the square problems, we get something with a square root in the answer. Sometimes we get nice integers or nice fractions. And sometimes we've even gotten things with I in it because we've gotten the square root of a negative, like the one we talked about when we were going over homework today. Quadratic formula will also work on all of them. But my opinion is it is much, 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 much easier than completing the square. So must have it equal to 0 or the quadratic formula does not work. And then the quadratic formula says x is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. What we mean by that, a is whatever's in front of the x squared. B is whatever is in front of the x. And c is the one over here by itself. And it includes the plus or the minus sign that's in front of it. And you may have noticed I said the opposite of b. It's okay to say negative b. I just like to say the opposite of b because when I say negative b, I think, oh, I've got to start with a negative number. And if b happened to already be a minus something, I need to change it to a positive here. The two biggest mistakes I see students make have to do with whether that b gets a plus or a minus sign. So remember out here in front, it is always the opposite of whatever you had in the equation. And here's the biggest mistake. If b is a negative, that b squared means that negative times negative, so you're always going to end up starting with something positive right there inside that square root sign. So just a warning, that's what I see most of the time. If you are a person who can remember the formula better with a song, just do a Google search, quadratic formula songs. There's a bazillion of them. Find one that you like and learn it that way. But I do need everybody to have this formula memorized. It is one you'll use for the rest of the time you're taking math at least. Okay, so let's try quadratic formula. Let me write it down here so it's in front of us. X is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And I need to identify one way or another what each of those would be. A is the number in front of the x squared, so a is 2. B is the number in front of the x, that's plus a negative 5. So b is a negative 5 here. And c is going to be the 4. And I do want you to show me what's going in where when you use the quadratic formula. Don't just do it all mental math and try to write down what you get. No, you don't necessarily have to write the times ones and some things that are that easy. But for the most part, write it down. You'll make fewer mistakes. So x is the opposite of b. The opposite of that negative 5 is a positive 5. Plus or minus the square root. You can write negative 5 times negative 5 if you want, or you can think negative 5 is 25. Notice it's not negative 25. That's one of the ones I was just talking about. Negative 5 times negative 5 is positive. Minus 4, A is 2, C is 4. I'm going to write that down so I don't get myself mixed up here. All over 2A. So let's simplify. 5 plus or minus 25 minus. I only had the one minus sign, so that is a minus there. 4 times 4 is 16, times 2 is 32, so minus 32 all over 4. So that means that I have 5 plus or minus, negative 7 over 4. What do I have to do about that square root of negative 7, Griff? I had to change that to a root 7 times I, and it's complex, so I can't do one big long fraction bar. So I'm going to write that as 5/4 plus or minus the square root of positive 7 over 4 times the I. And those are my two answers. Notice I have two complex answers, one with a plus, one with a minus. No real answers, only complex answers. So is everybody good so far with this one? Okay, now we're going to do the same one by graphing it on the graphing calculator. When we graph a parabola, when we graph a quadratic, what shape do we get? And what does a parabola look like? So it's going to look like the U, either right side up or upside down. So that's what we're going to start seeing on our calculators. So same problem we just did, 2x squared minus 5x plus 4 equals 0. And we got two complex solutions on that, so keep that in mind. Almost the same right here, 2x squared minus 5x plus 4, but now it's equal to y. Would you agree that if y equals 0, those two are the same? Okay, so the points where y is 0 on my graph are going to have something to do with those complex numbers that I just found. So we need to enter this one on our calculator. So I'm going to get my screen back up here also. I want you to get on a graphing page, and we're going to enter this as a function, not a relation. So when you hit tab, when you hit the tab button on yours, if it says F1 of X, you're good to go. If it says relation, you need to do menu, graph entry edit, and then select number 1 for function so that you're back to F1 equals. And then we're going to enter that y equals equation on the right up at the top, 2x squared minus 5x plus 4. We already have the y equals on the left. We don't do another equals y. And then enter. And does everybody see a parabola? Yours may be wider or skinnier. If your window dimensions are different, mine's on window standard. Does anybody not see the vertex where that parabola bends? Does anybody have yours where it's part way off the screen or anything? So hit menu, window zoom, standard. We'll work on this one. So 2x squared, you don't do the equals 0 on the end.
Oh, okay.
Because we're doing the y equals 1. Okay, everybody else able to see it okay? Okay, now we're going to talk about a few things about this parabola. One of them is explain why there are no X intercepts on that parabola that you see on your calculator. On your calculator, just so I have it all on one screen, we have a graph that looks kind of like that, and it does not cross the x-axis. If I am on the x-axis, if I'm right here, what's my y-coordinate? Everybody good with y0 right here? Or over there, anywhere on that axis, y is 0. That means if y is 0, I'm back to this one. There are no real numbers for y can equal 0. So I can't have 0 and have that parabola crossing the x-axis, because that's where y would be 0. And all of these numbers on this x-axis are real numbers. There aren't any imaginary numbers on that number line. So you would write the sentence, complete sentence, there are no x-intercepts. Copy this down because you're going to have a bunch of these on problem sets. There are no x-intercepts because the related quadratic has only complex solutions or has no real solutions. I don't really care which way you word those last few words. Does that make sense to everybody? Now, when you're doing these by graphing on the calculator, you're also going to be expected to label the critical points on your graph. So my graph clearly looked like the bottom of the U was in that first quadrant. Does yours also look like that? Sometimes you can't tell. So you're going to have to let the calculator check for you. If your dimensions were really squished, it might look like it was on the axis. I want it always to clearly be, even if you have to change it a little bit from how it looks on your calculator, to make that vertex clearly where it belongs. So we want to get the coordinates for this point. And this is also a critical point right here. Now we know how to do y-intercepts because that means 0 comma something for that point. Yes? So if x is 0, here's the equation for that parabola. If the x's are 0, what's y equal? In this equation, if I put zeros where I just drew them in, what does y equal? It's going to equal 4, so this point is 0, 4. Let's get the vertex with the help of the calculator. And let me see what my settings are here. Menu, 8. I'm on float, so I'm happy with, I'll get to see enough decimals there. So I could just cancel out of that or maybe escape out of that. Okay, when we wanted to find a critical point before, when two lines crossed, what do we have to push to get to where we said, calculator, help us find a special point? What do we have to do, Nicole? So menu, analyze graph. But now it's not an intersection because I don't have two things in there that are crossing. I want to find that lowest point on the U. What do you think? What word do you think means lowest point? Minimum. If it turned upside down, I might be finding the highest point, but for this one, the minimum. And then it's going to be just like you did with intersection. Move that vertical line to the left of the vertex and to the right of the vertex. And you see its coordinates. And then on your problem set paper, you are going to label that. So 1.25, 0.875, and if it looked like it was on the axis, you'd look at this and say, nope, they're both positive. You can only make it look like it's on the axis if one of those is 0. But because those are both positive, you know it's got to be in the first quadrant. So we label that the vertex, whoops, is, what was it again, 1.25? Thank you. And that would be what your graph would look like and what your sentence would look like, since it asked to explain why there were no x-intercepts. Does that one make sense? Okay, on your calculator, do menu 1, 4 to clear everything off of there. and enter for yes. And we're going to do another one. Is this one in the right form to start using our quadratic formula? Nope, we got to make it equal 0. So I like to start with a positive x squared, so I'm going to move everything to the left. X squared minus 3x, whoops, minus 28 equals 0. Oh, wait a minute. Is a 0? There's no number in front of the x squared. It's 1. There's that invisible 1. B is going to be the negative 3, and C is going to be the negative 28. X equals, the opposite of B will be positive 3, plus or minus the square root. B squared will be negative 3 times negative 3, or positive 9, minus 4. A is 1, so I don't really have to write that one down. C is negative 28, so minus 4AC, all over 2A, and again, 2 times 1, I don't really need to write the 1 down. So this time I have 3 plus or minus the square root of 9 plus 112 over 2. So I am looking at 3 plus or minus root 121. Hey, no imaginary this time, so I don't have to worry about an I. Over 2, does that mean I'm finished? Yeah, why not? Because we know the square root of 121 is just 11, so we have 3 plus or minus 11 over 2. Now am I finished? Yes? No? What do I have to do? So I have to do the 3 plus 11 is 14 over 2, so that's 7. 3 minus 11 is negative 8 over 2 is negative 4. So 7 and negative 4 are my solutions. Integers. That means I could have factored the thing in the first place. I could have said that this was x minus 7 times x plus 4 equals 0, and I would have gotten the same answers by factoring, right? Let's see what happens when we have integers, or when we have real number answers and not imaginary numbers. And let's graph this on our calculators. So that means we are going to need to graph x squared minus 3x minus 28 not equals 0, but y equals that. So back to the calculator to enter that. And this is looking kind of strange. I can tell it's a U, but the bottom of it is way down there somewhere. So I could do zoom fit and play with it. Another thing I could do is I could say, I wonder what the Y-intercept is going to be, because I'm going to have to go down at least that low, right? So if I put x equals 0 in this equation, what's y? Negative 28. So I know my Y-intercept is negative 28. So I'm going to go down to, on mine it says negative 6.43. I don't know what yours says down at the bottom. I'm going to click on that twice, so I've got the box with a little blinking cursor in there. And I'm going to backspace and do negative, how about 40? I know I've got to go at least lower than negative 28, so I'm just kind of guessing. Maybe I really needed to go to negative 50. I don't know, but let's see what happens here. Are we good with that? Okay, this one, I can clearly tell that my vertex is in the fourth quadrant. And if I wasn't sure, and so that I can label it on my graph, menu, analyze graph. Once again, the lowest point is the minimum, left and right. And now we have those coordinates. Remember, we also are interested if y is 0, then it's the same as the equation we just solved. So I want to find these x-intercepts. So menu, analyze graph. X-intercepts are for y is 0, so that we choose 0. And go to the left and the right, but make sure you only have one of them in between the lines. You can't come all the way over here to the right and get both of them that way. And then we repeat it. Oh, it crosses the x-axis at -4 and 7. Do those numbers sound familiar? Cooper, where did you hear them before? They're the answers we got when y was 0. Does that make sense? Y is 0. So these are the numbers we get when y is 0. So to finish our sketch here, we're going to draw it so that it comes down here with a vertex in the fourth quadrant. This was -4, right? Am I remembering the numbers right? This was 7. We said this was -28. You can put the zeros with those if you want to. And what was the vertex? 30? No, 1 point, 1 point what? 1.5, -30.25? Did others get 2.5? Fix your settings on there like I showed how to check to make sure they're on float. And that would be what your sketch would look like. Okay, one last thing that I need to squeeze in today. I think we can do it. I need you guys to take really good notes on this. You are going to be asked this question over and over and over on your problem sets, and this is what you're going to have to show, and you don't get to skip steps. So take good notes on this. When you derive something or prove something, you're not doing anything mental math. You have to present every bit of it as evidence. So it all has to be written down. It says, begin with ax squared plus bx plus c equals 0. So we begin by writing that down. We're going to complete the square on this. When we complete the square, we want the x squared and the x on one side and the number on the other side. So we're going to move the c over here to the right. But we also know that we need to start with 1x squared. So we're going to divide everything by a. So when we move this over, that becomes a minus c over a. And on this side, I now have 1x squared plus, and I'm going to write that as just b over a times the x. So I don't get mixed up and try to use the x in the next line. So is everybody good to that point? Completing the square, we know we need a short parentheses that starts with 1x, and we have to square that. To get the number that goes down here, we have to take 1/2 of that number that's in front of the x. So that means 1/2 of b over a. So that means multiply 1/2 times b over a, and we have plus b over 2a. Then we know that we have to square that and add it to both sides. So we had to take whatever that b over 2a is and square it. So it helps me if I write it down like that on the left, and then I'm actually going to square it out on the right. B over 2a times b over 2a is b squared over 2a times 2a is 4a squared. Okay, I know when I'm adding fractions here on the right, I need a common denominator. So I need to multiply this one by 4a over 4a, and then I'll have 4a squared for my denominator. I also know when I'm adding, I can switch the order. So I'm going to put the b squared over here on the left and the minus 4ac over here on the right. Starting to look a little bit familiar? B squared minus 4ac. Kind of looks like we're getting there. Next step is going to be to take the square root of both sides and put our plus and minus sign in front on the right. That means that I have x plus b over 2a equals plus or minus the square root of the numerator over the square root of the denominator. Square root of 4a squared is 2a. So I have that plus or minus square root b squared minus 4ac over 2a. Same denominator over here, but I need to subtract that on both sides. So that means on this side, I now have the minus b over 2a. And that should look like your quadratic formula. Questions from anybody?